Okay, well, here you see the finished graph, including our results, the approximate coordinates at this point, the approximate coordinates at this point, the indication that the graph is level here, as we've already seen, and yeah, more details, some estimates that we made, and we'll see how all that works out. Let's go ahead and do the math of the situation, do the calculus of the situation. Okay, so a peak or a valley, that is a relative maximum or relative minimum, occurs when the first derivative is 0 and the second derivative either goes from negative to positive as it does here, or from positive to negative as it does here. You get a minimum when the first derivative goes from negative to positive, a max when it goes from positive to negative. Now remembering, I'm assuming that we know that the first derivative can be identified with the slope of the graph. So the slopes go from negative to positive, or from positive to negative, means the derivatives go negative to positive, or positive to negative. Okay, well, our function is this. Now, we want to find where it's level. Those will be our critical points, where f prime of x equals 0. Well, the first thing we do is we multiply the function out. Now, I chose to multiply the first two binomials to get this, and then multiplied that, distributing over the addition here, and I got this simplified to this, and everybody seems to have verified this, so pretty sure that's right. Also, the results come out pretty good, so pretty consistent with our estimates. Okay, so we easily find the derivative and the second derivative. I'm not going to go over how to do that. You can verify that if this is your f of x, then this is f prime of x, and this is f double prime of x. We find that f prime of x equals 0 then by setting this expression equal to 0. And again, I'm not going to go through the details. We use the quadratic formula because this thing simply is not going to factor. And we find that this occurs when x equals this expression, either 12 plus the square root divided by 6, or 12 minus the square root all divided by 6. And we then approximate these results. Then we get, I did this in my head, so in my head in class, so it's possible that these are wrong, but this wasn't a very difficult square root to estimate, so I'm pretty sure I'm within a tenth on both of these, and no more than off by a tenth, I don't think. Okay, so we get x equals 5.3 or negative 1.2. Now, just to check my estimate, check that out with the picture. Okay, we see that it looks like this minimum here occurs about halfway between 3 and 7, but the way the graph came out when I drew it, and I didn't know in advance, the way it came out when I drew it, the minimum was a little more than halfway between here and here. That's because of the way the shape kind of articulates on both sides. There's no guarantee that I was right about that, but I lucked out. Okay, so this x value being 5.3, the x value at which f prime of x is 0, seems to fit the graph that I sketched quite well, as does the negative 1.2. F prime of 0 at x equals 1.2. Well, if this is 4, then this is 2, and half of that is 1, so negative 1.2, that looks like a pretty good estimate of negative 1.2. Very consistent with the graph. Wouldn't hold up to really close scrutiny, but it looks pretty good. So it looks like when x is negative 1.2, the graph does level off. So we test to see if we have a maximum or minimum. Now, I used the second derivative test, and I noted that when x is 5.3, got a little smudge there. Not going to be able to deal with all of those, but let's get this one. Looks a little better. If x is 5.3, we could evaluate f double prime of x, but there's no need if we just want to determine whether this is a maximum or a minimum. If x was 5, 6 times 5 would be 30, 30 minus 12. If x is 5.3, well, this number's still going to be even bigger, but it's already big enough to clearly be positive. 30 minus 12 is clearly positive. So f double prime of x is positive, which implies that we have a relative minimum. Once more, f double prime of x positive means f prime of x is increasing. F prime of x increasing, well, again, negative slope to zero slope to positive slope. The slope is increasing. The slope is your f prime. So this is completely consistent with a positive second derivative and is a picture of a relative minimum. When x is negative 1.2, f prime of double x is negative, and that gives us a relative maximum for reasons that I've explained many times and we'll go over again. I'm sure you're tired of hearing it. Okay. So, confirms we have a relative max and a relative min. Now, we estimated the coordinates of these points. And the estimates we came up with were about 100 with a question mark and about negative 58. And should have had a question mark. That one definitely should have had a question mark. If we plug in x equals 5.3, we don't do so hot. We get negative 36, unless I've got some kind of an error in my mental arithmetic. But this is pretty close to 2 times 2 times 9, which would be 4 times 9 is 36 with a negative. Now, could be 38, could be 34. But it's close to negative 36. It's not close to negative 58. So I think we kind of blew it with that estimate, but it's probably not the fault of our estimate. It's more the fault of how I drew the graph. So if I was all proud of getting my zero or my minimum point to the right x coordinate here and here, I'm a little less proud now that I realize that this should have been a lot shallower at this point. If this is 84, then this would be 84, and this would be more than half of 84, so it's certainly more than lower than negative 36. Okay, maybe it's not negative 58, but it's clearly too low to be negative 36. This one worked out really well. We got something very close to 100. Plug in negative 1.2, evaluate it. We get something very close to 100. So that was really good. So, and I did this one before I did this one, so I was feeling really proud. Then I did this one, figured out that this was it just doesn't look like negative 36, so I don't feel quite as good as I did. It's very useful to play this kind of a game. Try to draw the graph as best you can. Think about why it behaves the way it does. Estimate your results, and then see how well you did. It causes you to think about these things spontaneously in a much deeper manner than you would if you were simply following a bunch of rules. Although, when you're first doing this, you probably want to follow a bunch of rules fairly carefully. Rule being, take the first and second derivatives, find your critical points, and then either do a first or second derivative test to see if you got a max or a min.